Okay, in this video, we'll explain the architecture of the system that we're going to build from scratch with some of the various Aria and Tanzu services by VMware. Some of this is still a work in progress, but we only expect minimal changes going forward. So beginning in the lower left-hand corner of the diagram, we have a Git repository consisting of a single front-end web MVC application, two back-end web APIs, and a single background worker process. All of these are written in C# on .NET Core. And it started out with the weather template project that comes with Visual Studio, but we'll expand on this a bit and be creative. Instead of returning random numbers, for example, we'll go out to a real weather API external to our environment, as you can see hosted down here just outside the borders of our diagram. And we'll get real-time weather forecasts based on user input. Now, along the top, in the teal color, we have our VMware Aria and Tanzu services. In the middle, we have our AWS resources in orange, and along the bottom in blue, we have our Azure environment and associated resources. Finally, any activity that's going on in either of our clusters will be captured in Aria Ops for Logs service on the right. So let's pick it up with TAP, Tanzu Application Platform. We've deployed this as a multi-cluster environment hosted on both EKS and AKS. Now, TAP generally consists of four main parts, right? View, build, run, and iterate. But to keep things simple, we're just going to host one view cluster, one build cluster, and two run clusters. Now, the view and build, they'll be hosted on two key EKS clusters respectively. Our first run cluster will be hosted on our third EKS cluster, and our second run cluster on an AKS cluster in Azure. Now, all of the container images that are necessary to build and install and run TAP will be hosted in this Azure Container Registry on the bottom here of the diagram in the Azure blue box. Now, this registry will also store images for our apps that Tanzu itself will build, that TAP itself will build, our MVC apps, our web API apps. Furthermore, any images that we decide to push from application catalog will also be stored here. Now, in the upper left-hand corner, beginning with Tanzu Mission Control, while we could have deployed the TAP clusters manually in each environment with their respective tools and so on, we're going to stand up our TAP clusters with Tanzu Mission Control, and we'll do this with the Mission Control CLI exclusively. We're going to stand up from scratch 3 EKS clusters through the TMC CLI. We'll also create our AKS cluster, but we'll create that manually and attach it to TMC later after it's been created. Now, this will give us the opportunity to see that TMC can both provision clusters as well as attach existing clusters. This gives us a central location for managing the lifecycle of our Kubernetes clusters across platforms. Now, moving over to the right, we have operations for applications, also known as Tanzu Observability. And here we see some activity going on here. So both MVC front-end app and API backends are going to push their trace data directly to the observability service in code using an SDK for C#. Now, we'll also, that's one mechanism for ingesting metrics. We'll also demonstrate a very likely scenario where an organization has already stood up some kind of APM, an observability tool, such as Prometheus in this case. Okay, these apps here are coded to generate metrics, which will allow Prometheus here to pull them into its own storage for later analysis. Right? Now, in the event the organization wants to onboard Aria Ops for apps, what we can do is set up an integration, also known as a proxy, to read the same storage used by Prometheus and import those metrics into our Ops for Apps service. This is a great solution if we're transitioning from one solution to Aria. Now, in the center of the diagram, we are grouping both front-end and back-end apps into what's called a global namespace within Tanzu Service Mesh. The global namespace will enable us to manage clusters across disparate cloud providers as a single unit, despite their location. Bitnami Application Catalog comes with a vast number of open source tools and services. We're going to make use of the Redis cache for frequently accessed data in our front-end app. Okay, and so Redis is just one of many of the other open source services that TAP offers out of the box. And then finally, we've got our backend data API running in our AKS cluster is going to use a PostgreSQL database for persistence. Now we're going to get this database image according to customizations that we can make and specify in VMware Application Catalog, such as combining an instance of the Postgres image on top of a base image that an organization has built according to company policy, security policies, and specific proprietary tools that they like to bake into their image. We combine those, the Postgres image and the base image, and store those into our registry of choice. And then finally, once again, all of our Kubernetes-specific logs can be shipped over to Aria Ops for Logs. Now, if time permits, as a kind of experiment, we're going to simulate streaming weather forecasts for every zip code in the United States every 24 hours by this background worker process. By pushing that data through another out-of-the-box Bitnami service, Apache Kafka. And this will allow the user to input their desired temperature, for example, for their next vacation, and the system will return places of interest or disinterest, for that matter, based on temperature averages according to the user's input. Now, we would expect a lot of data to flow, given that we'll be pulling 5-day forecasts for over 40,000 plus zip codes in the US alone. Okay, that does it for this video. You can find all of the relevant links for this project in the description below. Next time, we'll begin setting up our environment. Hope to see you then.